Hey students, alright, in this video we're going to be drawing the dissolving process. Now we know from previous work that that dissolving is basically interactions between solutes and solvents. And often it's interactions between negative parts and positive parts. So to understand how to draw the dissolving process, we have to know where those negative and positive parts are on the molecules. All right, well, let's start with water. All right, hopefully you know by now that water is a polar molecule, and it's polar because there's a difference in electronegativity in these atoms. So, which of these atoms is more electronegative, O or H? All right, O is more electronegative. So it's going to pull electrons towards it, and that means that this side is going to be partially negative. Okay, I'm going to drawing on my keypad here, so it's not the best drawing, but that symbol means partially. All right, I know it looks kind of like a weird duck, but it means partially negative. So this side with oxygen is partially negative, and this side down here with the hydrogens is going to be partially positive. All right, so basically, if we see, we want to put that partially negative symbol at the more electronegative side of the bond or molecule. All right, now I want you to try to do number 2 and 3 on that first page before you look at the next section. So just pause the video right now, try to draw the positive and negative sides in the right area, and then come back when you're ready. Okay, so hopefully you got something like this, right? This is methanol, and again, that OH bond is superpolar. So the partially negative side is going to be on the O, and the partially positive side is going to be on the H. And this side over here is going to be generally positive too, because those CH bonds are nonpolar, and the electrons are getting pulled over in this direction towards the O. Now this molecule, this big mamba, is sucrose. And we can see here each of these points is a carbon atom, and there's going to be hydrogen atoms. They're not shown, but there's going to be hydrogen atoms coming off the carbon. But those are all nonpolar. The main thing we want to focus on is these OH bonds. Anytime we have an OH bond, we have a positive and a negative part because that OH bond is polar. So I didn't draw it on every single O and H, but every O is going to have a partially negative side and a partial, and then every H in the OH bond is going to have a partially positive side. So there's going to be a lot of polar segments on this sucrose molecule, which means there's going to be a lot of potential for interactions. Okay, so now we're going to look at the second page. We're actually going to be drawing the water molecules in the right orientation. So let's start with NaCl. Now NaCl is ionic, and we can see that it's actually going to dissociate in water. It's going to split apart into ions. So here's our free sodium ion, our free chloride ion, and we need to draw water in the right orientation here. Well, this sodium atom is positive. So are we going to draw it with the O or the H pointed towards sodium? Well, since O is negative, the O of water is going to be pointed towards sodium, and the H's are going to be pointed away. So I'm only going to draw one water molecule here, but it would be surrounded with water molecules. There'd be negative oxygens all the way around sodium. And then we're going to draw these dotted lines to show that there is basically an interaction, a type of intermolecular force happening between this positive sodium and this negative H, right? That's part of the reason why sodium chloride dissolves so well in water. It's because both water and sodium chloride have positive and negative parts that can interact. So they're happy to have these interactions because positives and negatives are attracted. Now remember that there's going to be a lot of water molecules around them, kind of like this here. Okay, so I'm not drawing all of them because it's too hard on my keypad, but there's going to be a lot of water molecules around there. Okay, All right, and the same way, we have a negative chloride here, and the positive H side of that water is going to be facing the chlorine. And again, there's going to be some interactions here between the positive H's and the negative chlorine. And again, I'm just drawing two here, but it's going to be surrounded by water molecules. All right, so that is how water is going to look when sodium chloride dissolves and dissociates in water. Okay, one more example we're going to do together, and this again is sucrose. So we can see we have all these OH bonds here, lots of different polar segments, and each of these segments has a negative O and a positive H. All right, well, we're going to have, again, the positive H side of the water is going to be attracted to that negative O of the OH bond on sucrose. It's going to look kind of like that. But for the H, the O in water is going to be facing that H. So the really important thing here is to draw the water in the right orientation so that positive and negative are facing each other because they're attracted. Okay, now again, I could keep going, but you get the idea. In a real water and sucrose situation, there's going to be tons of water molecules surrounding the different parts of sucrose, with all the O's facing the H and all the H's of water facing the O. But I think you get the idea, okay? So finish the rest of the practice on your own, and then I'll post the answers online for you to check. All right, bye.